Alrighty, so let's get started. I hope everyone's having a good day. Welcome to Cookies and Cram, ITI1120. So today we're going to go over classes and recursion. So I'm assuming you guys have done a fair bit of that and you're going to be familiar with everything I'm talking about. But if you're not, don't be afraid to either cut me off and ask me a question or use the chat to ask me a question. So let's get started. Let me just pull up participants. Everyone can see my screen fine? All right, so the itinerary for today, we're going to do a classes review and a recursion review. So beginning, we have defining a class. Then we're going to go over overloading. After that, we're going over designing container classes, and then inheritance, a little bit about custom exceptions, recursion basics, and then recursion examples. So the basics of creating a class. So we have the classic example here, the point class. I'm sure you guys went over this in class. So the point class has set X, set Y, get the point, and then move the point. And so how you create this is you create the class. You have class point, and then you have the function, you define it set X, and then you use this self parameter here. This refers to the instance itself. So the object, when you call it, that's what self is. And then X coord is your X coordinate. And then what we do here is we set self.x. So the instance is X equals whatever you set it as in the parameter. So equals X coord. Remember that self.x is always on the left side. So whatever you have here, even if the name is X coord as well, if you put self.x coord, it creates a new instance variable called X. And then it puts it into the instance. So whenever you call, say you have a equals point, you initialize it, and then you do a.setX, you put, say, 1. If you do a.x and you call it, you'll get 1 back. Same thing for set Y. And then get Y, you just have the parameter self. And remember that self is always put as the first parameter in every class function, because this always calls the instance. This allows you to do point.get or a.get if you name it A. And then we have move. And move, you specify self. Again, you have the amount you want to move it in X and the amount you want to move it in Y. And then you define your function as whatever that means. So you do X plus the amount you want to move it, and then Y plus the amount you want to move it. So then here's the usage. You have A equals point. So this sets A as a new instance of point. And you know it's an instance, and it's not just referring to the class itself because you have these brackets right here. And this says, okay, we're creating a new point. A new object is being created. If you don't have this, and you say A equals point without the brackets here, then it's just going to refer to the class itself, to the container holding these functions. And so in most cases, that's not going to be what you want to do. And so here you have a.setX. Remember, you put the self in here, but you never need to specify what self is in the brackets once you actually call it. Self here is A, okay? And then self here is A again. And then when you set Y, you just specify Y coord. When you set X, you just specify X coord. And then a.get, remember again, there's no self, there's no parameters, and then it just returns and prints the point. Does that make sense to everyone? All right, perfect. So what if we wanted to initialize a value? So as you noticed here, there's no init function. When we create a point, the only option we have here is to create a point with nothing there, no X and no Y. What if we wanted to initialize the function? What would we do? Right here. We overload the init function. And the init function is a default function inherited from the class object from Python. And remember, every class has an implicit init function. Even if you don't call it, it still calls it. Even if you don't define it, it still gets called every time you make an object. And so what's overloading? Overloading is when there's an inherited function and you rewrite it to your own definition. So here we overload init. So 2 underscores on both sides. We put in self, we got x chord and y chord. And then again, we put self.x equals x chord, self.y equals y chord. And then this enables us to do this. A equals point, and then we set our x and y's. So next we have container classes. And this is a special type of class, special type of object. These include containers like arrays or sets. And in this case, we have self.deck. And so this has a container called deck, and it has 52 cards. Here, notice how ranks and suits don't have self. This means these are not instance variables, they're class variables, and they come with every single class. And so here you do self.deck. This is unique to every instance that you create. And so when you initialize here, you put for suit index. So for every suit in deck.suits, and then for every rank in deck.ranks, you match up and you initialize the deck of 52 cards. And so then we create deal card. And what this does is just pops the last card from the deck, removes it. And then we also have shuffle. And shuffle is just imported from random, shuffles the deck. And so when we shuffle, it shuffles the deck specific to the instance. And then notice here how if we call suits or ranks, we don't use self.suits and self.ranks. We use deck because these are class variables. Does that make sense to everyone? Okay. So next, I have a question. What happens if we write length.deck, knowing this is a container class? Or the length of deck. I can send you guys these slides in the Discord after. So does anyone know what happens if we do length and then deck variable, deck object? What do we get? Would it be an error? Or would it be the length of the deck? Error. Why do you think it's going to be an error?
Wouldn't it be an error because you haven't overloaded the length function for the class yet?
No, that's correct. We don't have the length. Although we do have a container here, we have an array of 52 cards. We know this self.deck is 52. So if you did deck parentheses dot deck and you did the length of that, that would work because arrays have a length function. But here your deck object does not. So what we do here is we overload length. So that's 2 underscores on both sides. We got self right here. And then we return the length of the array. So self.deck. And then it's going to work. And so here's the list of overloadable functions. And so you have add, sub, multiply. You have your representations. You have your strings. And then here we have length. And so here, say we did like a deck define add. That means we'd be able to add 2 decks. And then it would return whatever we set it as. And so it's possible to set add to something that doesn't even add. to any function that you want to set it as. Does that make sense to everyone? Okay, cool. Now, what about inheritance? What's inheritance? Inheritance is when you have an object that is another object. It inherits all of the functions, all of the variables of that previous object. So here we have another classic example. We have animals. Here, it doesn't inherit anything except for the object class. And every single object that you create inherits the Python object, even if you don't specify it here. It's implicit. And so we have animal, we have set species, which just sets the species as whatever you set it as. We have set language, same thing, but for language, and then speak. And it says, I am a bracket and I bracket. And then dot format just sets these variables inside of the bracket. And so this is our main class. We have animal. And then after this, we have bird. And bird inherits animal. Now, what does this mean? This means that bird contains every single one of these functions now. So if you did b equals bird, and then you initialized a new bird object, you would be able to do b dot set species, even though here it's not explicitly defined. You're inheriting it from animal. And that being said, you can overload animals' functions as well. So here you have def dot define speak, and this speaks, but here we overload it in bird. And so this, whenever we call speak, it's going to print this instead and not the animal one, even though they're the same name and even though we inherit animal. We overloaded, so we replaced with our own function. Is that good for everyone? And like I said, if there's any questions, anything you want me to elaborate on, if you want to see an example of this, just cut me off or you can type in chat. I can do it. All right, so then we have custom errors. Did you guys go over custom errors in your class? Maybe briefly? Not yet? Briefly, okay. Custom errors are super simple. So here we have an example called empty queue error. And this is a class that inherits the exception class. This just passes, doesn't do anything specifically. And so in queue, we can raise that error. And raising is like throwing an error. And so here we have class queue, we have dq. And so if the length of self is 0, right? If we have nothing in our queue and we try to dequeue, we can now raise empty queue error, which is one of our custom errors. And then you're able to put in a string here. And even though we didn't call a function here explicitly saying handling what happens with a string, it's part of exception. And then so if length is 0, then we raise the exception. And then if not, we return queue.pop, the top of the queue. And so here's the usage and then what you see. So you have queue equals queue, you create a new queue, then you do queue.dequeue, but here your queue is empty. And so here it raises empty queue error. And this is nice sometimes because it hides the functionality of your code. Or it gives you a more specific error. It tells you why this isn't working. And it gives you your custom error now.
Is it possible if we can see another example of this?
Yep. I can show you one after these slides.
Thank you.
So then, actually, you know what? I'll show you guys one now, since it's relevant. Let me get... Okay. Let me share my screen. All right. Does everyone see this?
Yep.
All right. Let's do class, and then let me think of an exception. Let's name this not a string exception, okay? And this inherits the exception class. Now we can just pass. We don't actually have to do anything here. And then so we have another class. This is just example. And then we have a function here called def concatenate. And we have self, we got string 1, and we got string 2. So here our function is going to concatenate two strings. And then here we can say, okay, if st1 is not a string, does anyone know how to do that? How would we put is not a string? Let me see chat. How do we check if it's a string or not?
Not equal to quotes.
Sorry, what was that?
Not equal to quotes.
Not equal to...
Like empty quotes.
Mm-hmm.
And then a colon at the end.
Okay. Then we can raise our not a string exception. And then in here we say, this is not a string. Or you know what? Instead of concatenate, we'll just check one. Check if string. So then we can create an example here. We have e equals example. And then we do e dot check if string, and then we can do string. What I meant here for check if string, I'm saying check if this is a string and not an integer.
Could you also do is instance, and then you, yeah. So is instance first. Your first you would put in st1, and then your second argument would be string, str.
All right. So we're going to check if string, and then so here, if not is instance. So if it's not a string, we say this is not a string. This is a string, so it shouldn't give us this exception. So it gives us nothing right here when we run it. And say we take out these, we run it again, it raises. Raises not a string exception, and it says this is not a string. And then you see it here again. Does that make sense?
Yes.
So you can pretty much do this whenever you don't want something to happen and you want to create a custom exception. You just do simple if statements, you do simple checks. And then if it doesn't satisfy your condition, you can raise your custom exception, which is just a class here that inherits exception. What is raise? Raise is Python's version of throwing exceptions. Yes, raise is for exceptions. So in Java, you have throw. You'd throw an exception. And then in Python, you have raising an exception. So this is what gives you this red text right here. And so here we could do def check if int self, and then we got I for int. And then here, since we have not a string exception, we don't want to put that for int. We do class not an int exception. And then we always inherit exception. And then we can also pass. Pass just means do nothing, pass by this. So here we say if not is instance, then we got I int, or is it integer? Int, yeah. If not is instance I, so if I is not an int, we can raise not an int exception. And then here we can say this is not an int. Then we can do e.check if int. We could put a string in, comment this out. We run it, and then it says this is not an int. It's our new exception. And this also stops your code. So notice how I did this. I uncommented it. And so now it goes through check if string. And then since it throws an error right here, it's not going to go through and finish your code. It's just going to exit. Does anyone have questions about that? All right, can everyone see the PowerPoint? Okay. So that's how you use errors and exceptions. So now we have recursion. What is recursion? Actually, before I go on to recursion, does anyone have any questions about classes? Any clarification? Are we all good? All righty, let's go on to recursion then. Recursion is a function that calls itself. So it's like a big game of telephone. So I said this example in the Discord, but say you're in line and you don't know your position and you want to know your position. You ask the person in front of you, you ask them what position they're in. They don't know either. And so that person asks the next person until it gets up to the first person in the line who does know their position. And then that person tells the person behind them and says, okay, I'm in position 1. And then in position 2, now they know that I'm in position 1 plus 1. So now they know they're 2. And then it goes backwards. It goes 2 plus 1. And then all the way up until it reaches back to you. And so recursion has 2 main components. It has base case or multiple base cases. And it has the recursive step or the recursive case, which is calling itself. And then base case is like reaching the first person and saying, okay, we can stop now. I know the answer. I know my position. So if I'm in position 0 of the line, I know I'm first in line. So I say 1. So I return a 1. And then the person behind me, the person who called me, I can tell them I'm 1. And so the recursive step is if you don't know the answer yet, you say, okay, keep finding it, keep going forward. All right, so here we have recursion, an example of recursion. This is a recursive function. And what it does is it prints n, and then it counts down. It does count down n minus 1. So it calls itself with n minus 1. So if we did count down n, what would happen? Say count down 3. It will go forever. Kind of. It'll stop. It'll stop at around 990, which is the maximum amount that you can go. Yes, exceeding depth. You can increase this depth in your system in the Python options, but it's not recommended. Usually 900 should be enough. It'll raise an error. And it's correct. So what's missing here? Why is it going to raise an error? No base case, that's correct. We're never telling it to stop. It always just keeps going. So the fix here is adding a base case. So we're going to say if n reaches 0, we can print blast off. And then until it reaches 0, we say print n. So say it's countdown n, we print 3, then we do countdown n minus 1, it goes here. It's not 0 yet, so it goes back, it's a 2, same thing, countdown n minus 1, so we do countdown of 1. It's not 0 yet, we print 1, and then once we reach 0, or less than 0, then we print blast off. So this right here is your base case, and then you got your recursive step. Does this make sense to everybody? Right, so remember the base case always tells the recursive function when to stop calling itself. All right, so we have an example of recursion. Here we have printing digits vertically, but recursively. What we want to do is say vertical 3, 1, 2, 4, and we want to print 3, 1, 2, 4 by giving it an int. So here's how we do that. Remember again, we got our base case. So if n is less than 10, we know there's 1 digit left. And then we print n. That's all we do. We stop. We don't go forward. Otherwise, if it's more than 0, then we call vertical and then n integer division by 10. So we're getting rid, we're chopping it off. And then afterwards, we print n modulo 10. So we're printing the last number that's there. And so this print only gets called after this returns. So this goes down, it goes deep up until it reaches less than 10, prints this. And then after it gets out, it calls backwards. And then it says, okay, now we can print because this is done. And so then it goes backwards again, and then it prints. But imagine the first person in the line, the person that knows, is here. Is it first number for modulo? Modulo is the last number. Modulo is the last number. So the first number that actually gets printed is this one. So if n is smaller than 10, we print n. Why is this the first number that gets printed if it's the last step? It's the base case, we're done. Does anyone know? If this is the last step in our recursion, all the way at the bottom, why is it the first number to get printed? Exactly, because the print statement isn't executed until that branch with the if is executed. Exactly. This stops the recursive steps, and then after that, we can go backwards and then we can print. That's correct. All right, that's the end of the slideshow. What do you want to do first? A couple recursion questions together or the Kahoot? You guys choose. Let's see, actually. I'll add a question. We'll do Kahoot or questions. Kahoot questions. All right, let's see. If it's tied up, we'll do the Kahoot. I'll stop the poll at 1 minute. All right, it's tied up, so we're doing the Kahoot. Those are the results. Okay, you guys ready? Yeah, now I have to pick. Okay. Everyone good? Everyone see this? Two more people, and then we'll start. You're just gonna watch the Kahoot? Okay, one more. All right. Looks like it's just you five. One person didn't join. Maybe AFK. Grind time, let's go. Let's start this. True, you can define it. Reason number one. This is when you completely replace it. Yes, overloading. There we go. Always, always, always. You always inherit the function from the parent class. It might be implicit. You might not have to redefine it unless you're overloading it, but you always inherit it. I'm going to skip this one because it's actually incorrect answer. I'll explain it later. Before anyone was able to answer on that one. Yeah, t.foo d. So t is the self, and then d is the variable that you call. Recursion question. N is right here, Funky Boy 7. Good job. Oh, actually, nobody got it. Never mind. We can go through this later, and then I can show you guys how to actually think about problems like this. And I'll show you guys how to use the debugger as well. Python debugger. it's 1,000. I can go over it later. Tell you guys why. Yep, you can have multiple. Or it can have none. That wouldn't be a good recursive function, but it doesn't always have to have one base case. Sometimes it's more than one. Oftentimes it's two. That one does not throw an error. It's actually completely correct. $120. Everyone got that. Wow. Axel's in number one. Zero. There we go. N square, that's correct.
Oh God. Oh my God. Mute your mic. Mute your mic.
Big question. There we go. First answer was correct. Does the following code print? Zero. That's right. You get a minute for this one. Six. Good job. Last question. Zero and none. That's right. Let's see what we got here. Congrats, Axel. Good job, everyone. Thank you for participating. There we go. Do you guys want to go over these questions? Okay, let's see what we got. Back. Okay. So for this question, we do, how would we call foo for the instance t? We would do t dot foo d. Hold on, actually, let me go to, go to the Kahoots. I'll do this instead. Okay. It's question number 1. How would we call foo for the instance t? Does anyone not understand why it's green? Any questions about that? It's green because you have T, which is the self, and T equals thing, right? T is the self here, and then T dot foo D. All right, yeah, that makes sense. Question number 2. The following code throws an error, true or false? Why is this false? Anyone guess? This code actually works. It's because here we're calling thing. Yes, thing represents the object. That is correct. And so thing is actually a new object, even though it doesn't have a name. We didn't say T equals thing. It's still a brand new object. It's initialized. And that's why you can do T.foo_D, because the self here is actually the brand new initialized thing. So because of that, this is possible. Yes. So you can either include thing in the print function, except you're never going to be able to use thing again. It's just an unnamed variable. It's there in your memory. You have no name pointing to it. You'll never be able to use it again, but you can print and you can call it once. Yes, if you don't have to use it, you can do it this way. So then the next question, what does the following code print? And so here, since this is an object and D is 0, we call the object, the instance, we call that .foo and then D, and D is 0, so it prints 0. So then what does the following code print? We have thing.foo_D, but we're printing thing.foo_D. The answer here would be 0 and then none. Does anyone know why? Why is this none here? Why is it not 0, 0? Or even none 0? The difference between this one and the previous one is that here we return A, and then here we print A. Foo prints 0, exactly. It doesn't return it. Right. The object does not exist. Right. We have nothing returning from here, so we're returning none automatically. And then so here, when we print the return of that, we have nothing there. So what is the runtime of this code? It's n squared, and it's n squared because you got one loop, length of array. You got another loop, length of array is n. And then you have here k in range of 3. And this is always 3. It has nothing to do with n. And so that would be 3n squared. And since 3 is a constant, we can drop the 3 and we can just say O of n squared. Total, yes, 3n squared, not n squared plus 3. 3 times n squared. Plus 3 would be if you have a separate loop outside of this loop, it's not nested. Say you have this 4k in range after this, then it would be n squared plus 3. Yeah, because it's inside. Okay, so how many times will print n execute in the following code? We have a local variable, n equals 0, inside the loop. It's the same variable as this. Range is 0, so it runs through, yes. Because n0 times anything would be 0. That's correct. Now what happens here? Hero is 1,000. That was another trick. We have n plus n temp. And so we have n temp, which equals 1,000. It was n at that time. And then n changes to 0. You got 0 plus 1,000 for I in range, 1,000. We print n. This prints 1,000 times. Here, what will the following code execute? The only difference is the addition and the multiplication in the for loop. That is correct. It's the only difference between the two, between these two. So what'll this execute? And this one's actually not too bad because you have P1 equals 0.12. You got P2 equals 0.10 and 12. And then you got X equals 0 here. This is the only stuff that runs, right? So you look at this after you see what runs. So you say, okay, P1 equals 0.12. Now you can say, okay, I see it initializes. X is 1, Y is 2. For the second one, X is 10, Y is 20. Then here we have F equals X, P1, P2. We don't call the function F. And then here we print X, P1, P2. And so we print X first, we got 0, P1, which is just a 0.12. And then here we got P2, which is a 0.10 and 20. Does that make sense to everyone? So we actually never ran the function f. We named a variable f. So here, when do you inherit a function from the parent class? This is always, if you have a parent class, you inherit all their functions automatically, even if you don't call them. It's because of, not necessarily. It's because of any class that you inherit. You always inherit the class object. But if you inherit, for example, bird inherits animal, animal is bird's parent, that means you inherit every function inside of bird that animal has automatically. You don't necessarily have to call it, as long as you inherit it. So what is it called when you replace an inherited function? It's called overloading. And then what would Funky Boy 7 return? Does everyone understand this one? We can actually run this through. Let's run this through the debugger. I'm going to stop sharing and then I'm going to reshare when my window is set up. Okay. All right. So everyone sees this. We're going to say, I'm going to create a Python file saying funkyboy.py. So let's define that. Funkyboy n. If n equals 0, we return 0. Else, if n equals 1, we return, and then else, we return funky boy n minus 1 plus funky boy n minus 2. That's correct. So we're going to run here funky boy 7. So we're going to print it. What does it return? It returns 13. Now let's take a look at that with the debugger. Get in a bit deeper. Has anyone here used a debugger before? In PyCharm or maybe VS Code? Nope. Okay. So what I'm doing here is by clicking in this column right here where the line numbers are, I click inside of here. This is a breakpoint. This stops my program. First time it reaches here, stops my program. So it reaches the if statement. It doesn't have to necessarily equal. It doesn't have to return true. But once it reaches my if statement, it stops. Okay. And in PyCharm, the way you do this is instead of run, when you double click, you do debug, or you can press the debug right here. Make sure this has the script that you want to run. So we debug Funky Boy. So here it stops. We see n equals 7. Okay, right here. These are our debugger variables. So we have n equals 7, and then this is our console. This is what's printing. So then we want to skip over. We want to step over. And so here automatically we know that n is not equal to 0. N is equal to 7. So we step over. This goes to the second check. It doesn't return 0. Second check, if n equals 1. This is also false. So it's not going to return 1. It's going to go to our else. And then what's else? Else is return Funky Boy n-1 plus Funky Boy n-2. So then this goes first to our n-1. This is the first one called. And so then, right. Okay, it goes to our n-1 first, does the checks. We can step over, goes in. Now it's 5, step over. Now it's 4, step over. Now it's 3. Does this make sense? It's only going through this one. This is the first one called. Step over, up until it reaches, here we got 1. So we return 1. Now we got 0. So we go in, it's the 0. And then we go back up our function. Why is it now 0? Okay, let's restart it and see. After returning 1, why is it 0? All right, let's go see that again. Okay. So we have 1 here, right? If 1, then n-1. You did not say if 1, then n-1. No. So we return 1 here, right? N equals 1. We return 1. So we go up 1. And then here we have our second function. This is Funky Boy n-2. And what was n here at that point? Let's go back up. N is 2 again, right? So we're back up 1 function. As you can see, we have a frame here that's gone, because we just returned 1. So we're back up. And so after that, we had Funky Boy when n was 2, we had a -1. Now we're going to our second one, n-2. So we're adding those together. So we can step over, we go into that one now. And then we go, okay, return 0. Let's return 0. We come back up, n is 2 again. So we just went like in, out, and then in, and then out again for our second time. So here n is 3. Then we go again, n-2, Funky Boy n-2. So n is now 1. We check that here. And then we return a 1. And this just keeps going. And then it keeps going like that. And then if n equals more, it keeps adding. Or I mean, it keeps subtracting. It keeps going in with n-1 and n-2. And then it does the same pattern until it reaches 7 again. Does the same pattern until it finishes. And then here it reaches 7, same pattern, and then goes back up, and then at the end it's done. It's a really long one. And then at the end, it returns 13. Very, very long function, but at the start, it always goes to the first one called. It goes all the way in. And then once this one returns back, then it starts entering this one. And then it does this whole function again. Does everyone understand how it works? How the recursive function works? So it always, like the point of this question is it always goes through this one first until it reaches one of these base cases. It's hard to wrap the head around. Yes, it is. And then after that, it goes into these. And then it checks again. So say this one applies again after this one. It goes through this one again until this one gets all the way to the bottom. And then it goes to this one once it comes back up. All right, so the next question. Recursive functions always have one base case. That's false, and we can see that here. We have two. We have n equals 0 and n equals 1. Those are our two base cases, and sometimes you can have 0. So what would wobble 5 return? Let's run this through the debugger and see. This one's an easier function. It only has one base case and one call to the recursive case. Def wobble n. Then we have our base case. If n is smaller or equal to 1, we want to return 1. Else, return n times wobble n minus 1. And here, instead of funky boy, we'll do wobble and then 5. Yes, you could have. Wobble was so that if you know what a factorial is, then this question wouldn't be a recursion question. It would be a question on whether or not you know factorials. But since you figured out that this is a factorial, that means you understand the recursion that is going on here, or you've seen this function before. So wobble was meant to hide the name. So here, this is just 5 times 4 times 3 times 2 times 1. Let's check that in the debugger. So here, we can go again, we can debug it. So we go step by step. N at first is 5. Then if n is smaller or equal to 1, then we return 1. This is not true. So we go to our else. Here we have return n times wobble n minus 1. So we got n, which is 5, then wobble n minus 1. We don't know what that is yet until we do it. So then we got n equals 4. We go down, doesn't hit our base case yet. We go in farther. And as you can see, our frames, they're increasing every time we return a new wobble. We're going deeper into the recursive function. Here again, we're going deeper in till we reach 1, then we return. Yes, since the frames are increasing, means the bottom frames are paused. Yes, until they come back up. They're not running anything in this case. So then we return, we're going back up, we delete the frames because we know what they are. We've reached 1, which returns 1. And then finally we have our answer, which is 120. Does that make sense to everyone? Yeah, okay. Does everyone get the debugger and how it works? Super simple to use. There's a bunch of functions here. Pretty useful, yeah. So instead of print functions, Sometimes I like using print functions, but most of the time the debugger is more useful. So now back to here. The recursive case can be defined before the base case. And this is true because I can say here, I can reverse this, right? I can reverse wobble and say if it's greater than 1, return this, right? And then else return 1. So I reversed it. I defined my base case after. But that doesn't mean that I can't do it. It still works the same way, gives me 120, but the base case is defined later after the recursive step. So finally here, we have what will Vlad123 return? So here, let's look at that through the debugger again. We have def Vlad of n, if n equals 0, we return 0, else we return n modulo 10 plus Vlad integer division n divided by 10. So this rounds to the integer. Make spaces, clean it up. Then we're going to call Vlad 123. Oops, we're going to print that just to see what it returns. That returns a 6. So let's take a look. What's going on here? We debug. And then we look into our debugger. At first, n equals 1, 2, 3. We see that right here, and we see that right here. We only have our single function frame right here. Vlad, which is part of Funky Boy. So then we go in, we see that we've reached here. So we automatically have an n modulo 10. We do that first. So n modulo 10 would be 3. And so plus Vlad integer division n divided by 10. And so next we get 12. So then we go in again. So n modulo 10, that gives us 2, plus Vlad integer division n divided by 10, which is going to be 1. So then we return. We got 1 here. We go out of the scope. Out of our frame, we go backwards. Well, n 0, we return 0. That's our base case. Now we can go backwards. So when n was 1, here we do n modulo 10 plus we had 0. So this gives us 1. And then here, n modulo 10, that gives us 2, plus we add 1 plus 0, that gives us 3. And then here, 1, 2, 3, n modulo 10 would give us 3. So we have 3, plus before we also had 3. Vlad in n divided by 10 here is a 3. So we have 3 plus 3, and that gives us 6. Does that make sense? Yep. Okay. So now we can go through a few questions. So let me start here. We have, let me stop sharing and then I'll just share this right here. Okay. So what do we have? Given a hidden list, so you don't know what this list is, of x0, x1, all the way up to xn, create a hidden recursive binary search. Not a hidden recursive, just a recursive binary search. So here we have our search. We have our parameters, which is list, and we have our target. Target here is 0. We want to find 0. I and j. So we know how to do binary search, right? Everyone knows what search is. Yep. Okay. So what's the first thing that we would do here? A base case. Okay. What's our base case here? Start and end. Okay. If len equals 0 or 1. Len here. Len of what? Of the list. Why is that? The list isn't changing. What happens when we do a binary search? We have two indices here. We have I, we have j. I goes to the start, j goes to the end. We go in. We go in. Return -1. Just return -1. At the base case. If length of list equals 0. Okay, let's try that. If length of LST equals 0. Okay, then we return -1. All right, what do we do next? Else no for loops in recursion, no. We're just calling the function over and over. So what's our else? If our length of the list is more than 0. So if it's 0, that means we found nothing, right? Then we return a -1. But else, we're still looking for something. We have to search it. Okay. We have to set up a mid. Perfect, perfect. Where do we set that up? Before if. Okay, let's try that. Mid equals, say, I plus j, right? Divided by 2. All right, I plus j divided by 2. Yeah, don't forget the brackets. Otherwise, PEDMAS is going to work against you. So then we have our mid. Okay. So we say if target is less than mid, you're greater. Oh, my bad. Less than mid. Okay. if list of mid, okay, if LST of mid, what with this one? What do we do with that? What do we compare it to? List of mid, if it equals to target, right? Then we can return, what do we return? Mid, right? We return where it is, because we found it. So now we have our other cases. If, we can say elif. What are the other cases? We got our two base cases here. We have length of list is 0, and then we have the case where we found it. Elif target is greater than LST mid. Okay, what do we do here? Except I is mid and J is still J. Okay, so we can say search, and then we do we want to do it on the LST where I is mid? So we got our target I and J, or I is mid now, right? But then in this case, LST would never become 0. So in this case, this would be wrong, or we have to change something here. We have two options. We either have I and J become the same, we use the same list, and then we can do it this way. Or we could do length of list is 0, but we keep chopping the list. Do you understand why this wouldn't work? By chopping, yeah, I mean slicing. Yeah. So which do we want to do? Length of list or cutting up the list? Or I mean, setting I. Slicing? We want to slice? Okay. So instead of this, if we want to slice up the list, what do we do? Can't replace these. Or, yeah, we'll still have to. But we also have to do list, why 0? 0, list, 0, 2. Yeah, this gives us our entire list. Maybe the mid? Maybe the mid, okay. So this gives us all the way up to mid. Including or excluding mid? No, mid. So mid to the end of our list. Okay. So if the target is larger, we want the right side. That's right. And then what is the I and J going to be? I is mid. Okay. All right. So we have this. Now what? Else. Opposite of elif. So we go search LST, and we have up to mid, target, and then we want I, and then mid. Is this correct? Yeah. Right. And then let's return here. Return. So we always keep returning once it comes back. Correct? Let's check if it's correct. So we're going to do print search. We got our X as LST, target. What is our target? Target is N. And then what's our I and J here? If we want to generalize this for all lists, 0 and 4, we can do that for this particular list. But what would be better, more generalized? X of 0. X of 0. Are you sure about that? What if we had 5, 6, 7, 8, 9? This would give us 5 and 9 as the I's. It's what's at position 1. Right. So then here we would have I equals 5 and J equals 9. Then our mid would be 5 plus 9 divided by 2. Those aren't the proper indices. So what would we do here to generalize this? It's for every case. Here to generalize this, we just put 0 because we know it always starts with 0. And then here we put length of X minus 1, right? Those are guaranteed to be the first and last indices. Okay, let's see if this works. If it gives us 0 here, we know we've got the right answer. If not, we can debug it. 0, perfect. Let's try another case. We want to find the position of 8. Oop. Something's wrong here. What happened? How do we know I and J are indices? Because here we're using them as indices. We're using mid, which is I plus J divided by 2, right? We're using that as indices here. So what's going on here? Why is this not working? If list mid equals target. A good way, if we don't know why this isn't working, a good way is to debug it. We see, okay, where is this breaking? Now let's check. We go in, say, okay, this is working, this is working. So we got our list as 7, 8, 9. We've sliced it once. So okay. We have our mid, list mid equals target. Okay, we have 3 objects here, but mid is 3. I got a feeling that it's going to break here. Oh, it does not. Okay. And then, oh, it actually did. Okay. So let's debug that again and see. Why did it become 3? So first we have mid is 2, right? So we have I plus 4 divided by 2, that gives us 2. And then we go in once. We check if list of mid equals target. We have 7 here. Is list mid equals target. We have 8, and then our list of mid is 7. It's not the target, so we go over. Else if target is greater than list mid, we go to the right side of the list, right? So we're slicing it. We start at 2, and then we go all the way up to 9, or 2 all the way up to 4 here. And then so we got our I equals 2. That makes sense. J equals 4, and then we got 7, 8, 9. Why is this not working? Does anyone see the problem here? What's wrong with that? Return list mid. No, theoretically that would return what we're trying to find here, our target. It would just be the same thing as return n. So no, we want to return the index, which is mid. But why is this not working? Looking at this information right here. There's no 4th index. That's correct. There's a second one. It's right here in the new smaller list. That's right. And so how do we fix this? We're slicing our list, and then we're using these right here, which are part of our original list. And then we're bringing them in one step deeper. So here, when we get mid, we get our new mid right here. Our mid is 3. We don't have a third spot here. It goes 0, 1, 2. So this is out of range. We have a third spot here. So what's a super simple fix that we can do here? J divided by 2. Mid divided by 2. Mid equals length of list divided by 2. Let's try that. Mid equals length of list divided by 2. So here that would be 3 integer division by 2. That would give us 1. Let's try this first, see if that works. We'll run it instead of debugging. Does that work? Gives us 1 now. Huh. This isn't the proper one either. 8 isn't that one. You know what I think the problem here is? I think the problem is actually slicing the list. So once we slice the list, our indices get all messed up. They're not the original ones. So here, instead of slicing the list, we can actually keep the same list and just simply switch up our base case, right? Our base case, instead of slicing the list and getting it down to 0, we get if I equals j. Once they get so close that they're the same. So would this work? Let's give it a shot. What do you think though? Just looking at this, does this make sense? But then mid does not change. Yes, mid does not change. That's correct. I plus j divided by 2. Okay, would this work now? Okay, yeah, let's give it a shot. 3, it worked. Let's try for 6. We're gonna try to find 6. That should be 1. That works. And then what about 7? 7 also works. 7's at 2. What about 9? I'm gonna try every number here. Oop, that doesn't work. There's one thing that we should change here. We want the position returned because we are trying to find a value. We're trying to find the position of the value. But once we try to find 9, it doesn't work. Why is that happening? In the last index, it's the last index. Because of len x minus 1. What do you mean? This error isn't an out of bounds error. There's a maximum recursion depth error. That means we're starting where we're never reaching this base case. I is never equal to j. Why is that? We keep bringing them closer. Let's take a look at our debugger then. Unless someone has an idea. So change the base. What do we want the base? Let's see. If I reaches position -1, what do you mean by that? Let's check out the debugger. So we're going in, target is larger, it's 9. We go again. Now we have I equals 2 and j equals 4. All right. But is that correct? Do we want I equals 2 and j equals 4? And let's go in again. I equals 3. Okay. J equals 4. So now they're right here. Okay, we're going to divide it. And then we always have mid equals 3. That's a problem. I plus j divided by 2 is always 3 now. We can go again. Our I and j is never changing. Now what's going on with that? problem here is that we have mid right here as I, but this gives us numbers that we already know are not the target. So how do we fix this, Sean? We know 8 is not the target. 8 is at position 3. So how do we fix this? We can restart to give you a better idea. So we have 0 and 4 as I and j. We go in, we have 2 and 4. This means we include 7, 8, 9, but we know that 7 is not the answer, yet we include it anyways. What can we do to fix that? So we don't need 7 anymore in the list that we check. You'd straight up remove it from the list. I wouldn't do that, because then 4 wouldn't be a valid j. We'd only have 4 items in the list, and that would be out of bounds. So do we add 1 to the mid? That's correct. We add mid plus 1. And that is because in lists, it's inclusive at the lower bound and then exclusive at the upper bound. So you can use mid here. Does that make sense? But then mid plus 1 has to be on the I. So we can try this. And this gives us -1. Yet we know we have a 9. So we have another bug. We have a -1. It is because I equals j. -1 is not the position. -1 means we haven't found it. How can we fix this? I equals j. Yeah, it does. Then I plus j divided by 2 is I and j. And so we have a 4 here. We can look at that in the debugger. So we get mid-2, mid-3, mid-4. But then we go through this check, I equals j, which is true. But we've actually never checked for mid equals 4. So there's our problem. We'd go straight to the return here, and we never even check if this is our target. How can we fix this? Instead of return -1, return mid. That would return the mid even if something's not found. We add an AND statement. Where do we do that? Let's try that. And LST mid. And LST mid is not the target. Now let's try that. Now we got 4. There you go. Now let's try it for every single number. We'll go 5. 5 is at 0. 6 is at 1. 7 is at 2. It's correct. Correct. And correct. There you go. That's a solution. Or you could do these checks before you do this check. Or you could do this check before this one, but this one covers it. Yeah. Yeah, let's try that. Let's try switching them and seeing if it works. So you can do else, whatever's in the else. This goes, check if here. And then that should also work. So you just switch the base case and the recursive case. Switch their order. So here we have two base cases, as you can see, if I equals j and if list mid equals target. Those are two base cases. They tell our program where to stop. Does this question make sense for everyone? Yep. Good, perfect. Let's go to question number 2. Oops. Well, since I already have the answer here, let's see why this works. So modify vertical so that it prints the numbers in reverse. And so here's vertical. Let's try vertical. 5, 6, 7. And that prints 5, 6, 7. Now let's try reverse. So why does reverse print it in reverse? And then vertical doesn't? There's an obvious difference here. These two are in different places. But what's actually happening here? Who can explain that? In reversal, yes, it does. It does do that. That's the function. But why is it printing 7, 6, 5 and not 5, 6, 7? Then integer division. Because the order of these. So here you're printing first and then you're going into the stack, into the frames, I mean. And then here, once you reach the end, this is your last print in reverse. This is the end. That's where you print the 5. Does that make sense? And then here, you print this one first in vertical. So it's your 5. And then afterwards, once you return out of the frame, you start printing. You continue in the other frame. Exactly, Sean. Yeah. Sean and Axel, you guys are correct. So reverse n, it's going to print 6, 5, 4, 3, 2, 1, just like that. And then vertical n is going to print the opposite. All right. So let's print all the numbers from 0 to n using the two common methods, which are loops and recursion. Let's try the loop version first. For loops, if we want to print numbers from 0 to n, what would we do? We're going to say inclusive. For I in range n plus 1. Okay. For I in range n plus 1. And print, what do we print? Print n? Okay. Let's try that. Print I. Is it print I or is it print n? I. Okay. Yep. Now let's try to do that recursively. So remember, you need the base case and you need the recursive step. What's our base case here? We've reached the end. And remember, we want to print n last. If length of n is not a collection of anything. If n equals 0, okay. If n equals 0, or is it equal 1? From 0 to n. Is n 0 or is n 1? It's our base case. The first one that we want to print. Depends on the question. 0 to n inclusive. That's the question. So 0. Okay. So what do we do here? We print 0. Yeah, we can print n. N is 0. There we go. What's our recursive case? We got the else here. Since this is the first one we want to print, what do we do here? Print n. And then return. All right, so which is it, guys? Return recursive print n minus 1. All right, let's see. Are you sure? Oh man. Okay. I'm gonna need you guys to work together here. I need one answer. Is this gonna work or is it not gonna work? No? What's it gonna print here? Wrong way around, 0 last. Okay. Are you sure? Nope. I need you to be sure. Are you sure that that's going to happen? You're sure? Okay. Alex thinks that it's going to print from n down to 0. Let's see. Print recursive print of, let's say n is 10. Or print recursive print. We don't need to print here. All right. Alex is right. Good job, Alex. Okay, so how do we fix this? We want to print from 0 to n, not n to 0. No, 0 to n. Why not print recursive print n minus 1? Return instead. All right. So when you suggest something, you need to have an idea of what it's going to do. So I'm assuming that you know what this is going to do. Print recursive print n minus 1. So what is this going to do? We return what? Print n where? Print n, then the next line. Print instead of return. Okay, recursive print n minus 1. What do you think this is going to do? That's your question. I don't know. You have to have an n plus. Where am I going to have the n plus? Line 14, n plus 1. Or n plus, print n plus. N plus, what is this going to do? We're printing n plus recursive print. Recursive print prints n. So we're essentially adding n plus none when we get to the bottom. What does that give us? Probably an error. We can check it. Yes, it gives us an error. We can't add int plus none. And we're still counting down 10, 9, 8. So this can't be the solution. Go back to what we had. So what we had, and this gives us 10, 9, 8, 7, 6. So other order, what does that mean? Everything in else goes to if, and if goes to else. Recursive print n minus 1 plus n. We tried that already. Recursive print n minus 1 returns a none. That's our problem. And plus n would be, even if we had an integer in recursive print that was getting returned here, which is a none, then this would just return an addition of integers. But we just want to switch around the order. So what's actually going on here is we're checking it's a 10. So we go in and then we print the 10 before we go into the recursive print. And so that's why we're getting the 10 as the first number printed. So we don't want that. We don't want print to print a 10. We want to print the 0 first. When n equals 0, we want to get to here before any other number. Yes, Alex. Alex is correct. So we have, instead of this order, we actually do this. We switch the orders around. But we have a problem here again, and that's being underlined. This code is unreachable. That's another problem. What can we do to fix that? Another pretty simple fix. because return ensures that we never get here. I don't think, yeah, Raymond. That would work. We don't need to return. We just need to print. So we call the function, and then that just works out. So here we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since we're never actually returning anything, we'd be returning a none here, either way. So here we can check that, and we can print it, right? Because now we're returning, and it's going to give us a none. And that doesn't give us what we want either. It gives us 0, because it goes all the way down, prints a 0, and then it gives us a none. Does this make sense? Yes. Okay. There we go. Now the last question. Oh, this was recursive factorial. So this is what we saw. Now let's write this in loops. So we have if n is smaller or equal, if it's less or equal than 1. I can send you guys this code in files if you'd rather that. Yeah. Okay, so we have our recursive factorial. Now let's convert that to loop factorial. Clip it. Someone clip this. Set up a factorial to 1. Okay. How do we do that? We have the function here, recursive factorial. We see what it does. Factorial for I in range n. Okay, we'll do factorial equals 1. Then for I in range n, what do we do? Factorial equals times equals I. Okay. Let's see. Are you guys sure that this is going to work? Then we return factorial. Is this going to work? You can have an if statement if there's a negative case. Let's make the assumption that it's always going to be a positive. I'm going to write the assumption here. Assumption positive. If for 0, where do we set that up? If for 0. Okay, if we have a 0, if n equals 0. If n, okay. Oh, so outside of here. Okay. If n equals 0, return 1. Okay. So you're sure this is going to work. What if our n is 5? Are we going to get a 120? Are we going to get the same answer with these two? 5 and print recursive factorial 5. We want to get 120 on both of them. We want them to be the same function. Change the range to start at 1. Why do we need that? What is that going to fix? because it will default to 0 for its beginning. Yes, and then we're going to multiply by 0, and then that's not good. So like this, range 1, this, n plus 1. So like that. That won't work. 1, 2, n plus 1. Yes, 1 comma n plus 1. So is this going to give us the answer that we want? 120 and 120? Yes. So you're 100%. Axel and Yosri. Is that how you pronounce your name? Yosri and Axel think it's a yes. What do you think, Raymond? By my voice, no. I could be lying. My voice could be lying. You need to be sure. Are these both going to give us a 120? Yes? Okay. What do you think, Sean? Double check 14, there's an underline. This is just saying we need 2 blank lines underneath this. And then this at the end says we need another blank line at the end. It's cosmetic. Okay. So everyone thinks it's both going to be 120. Let's see. 3, 2, 1. There we go. Good job. Good job, everybody. Nicely done. There we go. Good job, everybody. That's the end of the questions for today. Does anyone want any more clarification on anything? Or to go over another concept? Yeah, Raymond, I need you guys to be sure. Why the n plus 1 again? Because this is not inclusive. We go up to the number before n. And so if we want it to actually reach 5, we need n plus 1. Otherwise, it would go up to 4. So it'd be from 0 to 4. We want 1 to 5. All righty. Thank you guys for coming. I'm going to stop the recording. How do I do that? Stop the recording.